Okay, so this session in the AI course is on different representation schemes. So, why do we need these representation schemes? So, when we talk about knowledge based systems or things like expert systems, you need to do representation of knowledge in some way. So, of course, we have seen one way of representing knowledge, that is the predicate logic, for starting with the propositional logic and predicate logic. So, we are going to see other schemes in which we can represent knowledge. So, this actually came up only when they started working on knowledge based systems. So, many of these schemes are at the present not really being used that much, but they were used a lot when AI was developing, like in the 80s, etc. So, let us look at some of these representation schemes. So, most of these representation schemes actually are they try to represent the semantics of the sentences that we are talking about. So, the contents will be as follows. We will first talk about what are the issues in knowledge representation. In other words, what are the factors you need to take into account when you are going to talk about knowledge representation. And in the case of AI, how do we, what are the systems, representational systems that we have, and what are the characteristics these systems should be having. And we talk about some specific knowledge representation schemes. The first one is what is called the semantic networks. So, in the semantic networks, you are trying to represent the semantics of a sentence or a set of sentences, or maybe a concept. So, you are trying to represent that the semantics which is there in that. The second one that we talk about is the scripts. So, in the scripts actually you are trying to represent stereotypical situations. For example, what are the steps that you have to go through, or what are the actions that you have to go through, maybe in a basketball game or something like that, or if you go into a restaurant, what is the stereotypical set of actions that you are going to take inside the restaurant. So, the idea here in scripts is basically for natural language understanding, because when you do natural language understanding, you need to have some common sense reasoning. So, you need to know something about the topics that you are talking about. So, that is how human beings actually understand some things that are happening. So, for example, if you say that you went to a restaurant, everybody knows what is involved there, that you go inside and you sit down and the waiter comes and you look at the menu and you order what you want, and then you eat it and then you come out of the restaurant. So, this thing can be represented as a script basically. So, you can have a script for how a basketball game is played, or how do you ride a bicycle and things of that sort. So, when your natural language actually talks something about any of these topics, you can look up the script, or the computer will look up the script to find out what exactly is involved there, and get a knowledge of what is being spoken about. The next representation is the frames. So, in frames actually you are having data structures with slots, and these slots will tell you information about what is the object that you are talking about, and also it will have connection to other frames. And then finally, you have conceptual graphs. So, the conceptual graphs is very close to the semantic network, but the thing about conceptual graphs is that it takes care of things like negation and things like quantification, etc. So, because of that the conceptual graphs are also important. So, these are some of the main knowledge representation schemes that we are going to talk about. We may talk about others also, one or two. So, what are the issues that we need to discuss when we talk about a knowledge representation? First of all, the representation issues like generality and specificity. So, if you are talking about there will be when you are talking about a concept or an object, there will be something which is generally true for all such. For example, if you are talking about a bird, then you know that all birds fly, birds have feathers, etc. So, that is the generality that you are talking about, but there may also be some specificity, that is the particular bird that you are talking about. Okay, for example, it may be some bird which sings, or it could be like a woodpecker which pecks into the wood, etc. So, these are the specific things which you need to represent. Then you also need to see the exceptions. So, if you say things like all birds fly, then you may come up with a bird which does not fly. For example, maybe an ostrich or does not fly. So, when you come up with exceptions like that, you should be able to deal with those exceptions. And of course, you have the default. So, you say that if nothing is given, then you assume that the bird is able to fly, because you are inheriting that property from being a bird. So, you belong to the category of birds, and therefore, you are able to fly. So, unless some exception is made over there, you take the default setting. Then you have what is called the causality. So, what do you mean by causality? So, if something influences something else, or if something is the cause of something else, then that is the cause, that you are going from the node to its cause. And of course, you may have to deal with things like uncertainty, times, it may change in time. Okay, so, you have a data structure which or a knowledge structure which may change as time goes on, right. So, you need to take time also into account. So, what are all the schemes that are available, and the medium means how is it represented, what is the language that you are using to represent the particular schema. Okay. So, what are the representation schemes that we will talk about, right. So, we talk about semantic networks, conceptual dependencies. So, conceptual dependencies actually has some actions. So, these are what are called the primitive actions, and the meaning of the sentence is brought out, okay, in the conceptual dependency by using these set of primitive actions. Then scripts, frames, and you also have things like stochastic methods, connectionist methods, which are neural networks, etc. So, we will talk about the first few over here. And implementation, how is it implemented? So, it is implemented by using some languages like Prolog, Lisp, Scheme, and sometimes even C, Java, etc. So, this is the implementation of these schemes. Okay, so, obviously, we are talking about semantics here. Okay, so, when you talk about predicate calculus or predicate logic sentences, okay. So, you are representing we know very well that when we talk about predicate logic, it is a formal language in which you are representing it, and we know that you have inference rules and truth preserving operations, etc., because we have already gone through all that when we talked about the predicate logic. So, when we are talking about semantics, we are talking about what is the meaning of what you are doing, what is the truth value. So, when you say P implies Q, what is the relationship between the truth values of P and Q? And when you say associationist theory, it means that you are attaching some type of semantics to your logical symbols and operators. So, having said this, we will start first with the semantic networks. So, the first representation scheme we will talk about is the semantic network. So, as the name itself suggests, it is a network. Okay. So, it is a network which consists of nodes and links, and it has some semantic meaning attached to it. Okay. So, it displays objects or categories name in ovals or boxes, right. So, you have an oval, and inside the oval you have what are the objects, and you have connections between links. Okay. So, which gives the relationship between the two links basically. So, we have labeled ovals or boxes, and we have the label link. Okay. For example, you can have two ovals, okay, and the ovals could be so if we look here, okay, the ovals could be something like Mary and John, and you have a link which connects between them, which says that sister of. So, that is the relationship you have between Mary and John. So, you can have a member of link. Okay, for example, Mary is a member of female persons. Okay, so, member of the set of female persons basically, or in other words, Mary belongs to female persons. Then you have the sister of link between Mary and John. Okay. So, in predicate logic you would give it like the sister of Mary, John basically. So, you can use also subset links. Okay. Subset links are like the ones used over here. So, you are saying that female persons are the subset of the set of persons, and male persons is also a subset of a set of persons, and persons are a subset of mammals, etc. Okay. So, subset of. So, there are a number of relationships that you can use between the various objects that you have. Okay. Then we have the link which is associated. For example, here you have this link which is associated with this double box. Okay. So, what does that box represent? Okay. So, the double box represents something like this. Okay. So, what you are saying is that has mother. Okay. So, person has mother, okay, and that comes back this way because that is a female person. So, we have something which says for all x, if all x belongs to persons, implies that for all y has mother x y, okay, and y belongs to female persons. And we also have something which asserts that the person has two legs. Okay. So, for example, here a person has two legs, right. So, we are saying legs is 2. So, you have a small box here which says legs is 2. You could have others. This is just a simple semantic network which has been shown over here. Okay. So, okay. So, what happens is you have the inheritance reasoning that can be taken care of over here. For example, suppose you want to know how many legs Mary has, right. So, what you do is you go backwards from Mary, right, till you find the information about the legs. So, here you will be going backwards. So, Mary belongs to female persons and person, and here you have legs as 2. Okay. So, you can say that Mary inherits the property that all persons have legs equal to 2. Okay. So, the problem here could be become complicated when an object can belong to more than one category. Okay. So, you may have something like multiple inheritance and you may find conflicting values, but of course, these things need to be taken care of basically by whoever is working on the semantic network. Okay. So, this is one semantic network which is given here, and here is another semantic network. So, we have seen this where we say we are representing an event here, and the event is fly, a certain flying event. So, then these are all the links that you have. Okay. So, the person who flies is Shankar, the agent. Okay. Origin is New York, destination is New Delhi, and the time is yesterday basically, right. So, this is the way you can also represent events by using semantic networks. Okay. So, they say that you can also use universally quantified sentences, we will see that later. Okay. And you can use singly boxed and double boxed arrows applied to categories. Okay. So, obviously, that is because the some object belongs to that category, it has these characteristics basically, and some of the things which are missing as compared to the predicate logic is things like negation, disjunction, nested function symbols and existential quantifiers. Okay. So, what happens here is that maybe it is not able to take care of some things, but it is a very simple representation of what you have. Okay. Of course, afterwards the semantic networks were extended, so that it becomes equivalent to first order logic, as in Peirce's existential graphs. Okay. So, an extension of this semantic network is what is called the existential graph. Okay. So, if you look at the semantic network, it is very simple, okay, and you can easily visualize the steps in your inference procedure basically. Okay. Now, to improve the expressive power of the semantic network, they actually use what are called procedures. Okay. For example, if you are talking about say Mary and you want to know the weight of Mary, you can have a procedure which says if needed. So, if needed, it will or in some cases where it is possible, it will get you the weight of that, or any other procedure can be there. So, procedural attachment is used over there. Okay. So, when a query is made, a certain relation results in a call to a special procedure designed for the relationship. Okay. So, basically it represents what are called default values. Okay. So, for example, since it is inherited 2 legs from persons, So, everybody is assumed to have two legs unless specifically it says that a person has one leg. Okay. So, you are using the what is called the inheritance algorithm. Okay. So, what it does is, suppose you want to know whether Mary is has two legs, then you are going to go upwards. Okay. It is going to follow the link upwards from the from Mary, and it is going to stop as soon as it finds a value for legs. But if you see over here, you will see that John has one leg. So, how would you take care of this? So, basically you are taking from the node John, you are going to go, you are going to keep looking. So, you find legs equal to 1 first, right. So, it is going to take legs equal to 1 over there. So, the first value it finds for what it is looking for, that is what it is going to take. So, obviously, you have an exception here which says that John has only one leg. So, this is equivalent to saying, so the default is overridden over here by the specific values that we have. Okay. So, it is equivalent to saying in predicate logic, if x belongs to person and x is John, then legs x equals to 1, okay, that type of thing. So, what happens is that if you take a semantic network with a lot of exceptions in it, okay, then you find that it becomes a little difficult to work with it. So, if you have a lot of default reasoning going on and now and then you have one exception here or there, then for that semantic networks does well. Okay, so, you have nodes which represent facts or concepts and arcs which correspond to relations or association between the concepts. So, it implements what is called the inheritance, okay, so, and you could call it a conceptual graph in some way, right. So, for example, here we have the nodes which consist of objects and you have relations along the links. So, you have some very specific relationships, for example, is a, okay. So, we are talking about say a specific brick 1, right, and it is a brick and it is a toy if you are using it as a toy and the color is red. So, these are the properties or the relationships which are found along these links. So, here are some more examples. So, some of the relations you could have is color, part, support, purpose, etc. So, suppose I have toy 1. So, toy 1 is a toy and the purpose of that toy is to play, or you could have something like brick 1 which is a brick and it is a subset of block, or you can say a kind of AKO like they have put here block, and then if you want to find the weight of that block, you have a procedure here, okay, which will give you the weight of the block. And here we have say brick 1 which is a brick and the shape of that brick is rectangular, right, and it is a kind of block. But you also have a wedge which is a kind of block, but the shape is triangular, and you have wedge 1 which is a wedge, right. So, these are all just some examples of semantic networks which we have here, right. So, here you have a semantic network which is in the form of hierarchy, right. So, you have an animal. So, animal can breathe, it has skin and it can move, right. And then you have bird and fish which is a, okay, bird is an animal, fish is a animal, and then bird can fly, bird has wings, bird has feathers, etc. Then you have things like canary, ostrich, etc., which are specific birds. So, if you take canary, it is a bird and it can sing. Okay. So, obviously, all birds can't sing, but canary can sing and it is yellow. So, you find specific information of the canary here, but if you go up in this hierarchy, you can get other information that it can fly, it has wings, it has feathers, etc. And ostrich cannot fly, right. So, this cannot fly overrides the information that bird, that since it is a bird it can fly, okay, because it goes for the closest information that it has over here. Okay. And you can say like ostrich is tall, right. So, these are all specific information. And obviously, this gives you some type of response time depending on the complexity of a sentence, right. For example, a canary can sing, you will take from canary itself, but a canary can fly, you need to go up, okay. And a canary has skin, you have to go even more up, right. So, you need more response time for that. So, that is what this figure is basically trying to tell you over here. So, here is a semantic network to tell you the difference between snow and ice. So, you have snow, and snow is slippery, soft, white, cold, etc. So, you have this relationship between snow and cold. So, that is the temperature, color, texture, etc. And ice actually is the hardness, right. So, ice is hard and the snow is soft, basically the texture, right. So, these are different methods. This is a one way of representing the semantic network for this particular problem, right. So, semantic networks have been used in natural language understanding. So, basically the sentence which you are trying to understand will become converted into a semantic network, right. So, it is used in machine translation basically. Okay. So, you are defining the English words in a dictionary like manner. Okay. Then each definition leads to other definitions, etc. So, it is something like the knowledge graphs which they use nowadays. Okay. So, the knowledge graph is supposed to give you something like general information about the world. So, so when you look up the word, you traverse the network. So, you see this word is connected to some other word. So, what is the relationship between them, etc. right. So, all this is used in natural language understanding basically. So, here you can see three meanings of the word plant, right. The first one is that it is a living structure that is not an animal, frequently with leaves getting its food from air, water and earth, right. So, this is one meaning. Another meaning of plant is you have plant 2 here. So, plant 2 is an apparatus used for any process in the industry. Then you have plant 3 or the third meaning over here, put in the earth for growth. For example, put a plant or a seed into the earth, etc. So, here this is more complex semantic network which is used to represent this. So, how do you calculate inference? You need to go along the links of your network. Okay. So, inference is along the associational links and you need to find relationship between pairs of words. So, if you are starting with the particular word, you start outward, going outward from this word in a breadth first fashion, and you try to find some type of common concept. Okay. So, for example, if you want to find the connection between two words, right. So, you need to keep moving till you find a common concept between the two words. and the path between the two words passing by this intersection node is the relationship between them. So, that is how you carry out inference in the semantic networks basically. Okay, so the next logic that we are going to talk about is what is called the description logic, which is a little different from the predicate logic that we are looking for, and it is easy to describe the definition and properties of categories. Okay. For example, if you are talking about a particular category, you can use words like and etc., right. So, if you use and in brackets you can give all the information about that particular category, right. So, for example, if you are talking about to say that bachelors are unmarried adult males, you will have to say bachelor equal to and unmarried adult male, right. So, you are using words like and etc. Okay. So, we will see what all you can use in the description logic basically. So, there are two tasks in the inference task here. One is subsumption, checking if one category is a subset of another basically, and classification, checking whether an object belongs to a category. Okay. So, these two things can be carried out when you use the description logic. You have the classic language which is used, okay, which is a typical description logic language. Okay. So, we will see that in the next session. So, in this session I will stop it here.